My name is Trey Elkins, and I am the team captain for CS Capstone Team 12, the Oregon State University entry into the NASA Student Launch Initiative competition. I will specifically be talking about avionics development. We've had three primary goals, the first of which is the refactor and rework of the 900 MHz transceivers, which is our primary communication band running over XB Pro S3s. The goals of the system are to collect GPS data in real time, log it to an SD card aboard our microcontroller, filter the data down to a single packet type, and then send it back to the ground station for observation and recovery of the rocket after launch. Second goal has been the creation of a 433 MHz band backup prototype with a Texas Instruments CC1200. Essentially, it does the same thing as the 900 MHz transceiver system, but with less interference due to commercial unavailability, and introduces a redundant system in the case of any significant computer or electrical problems. Finally, we've been drafted to work on the Payload Ejection Controller, or PLEC, which operates over the 900 MHz band, and remotely sends ejection charge detonation triggers so that the charges inside of the rocket body go off and launch the rover out of the airframe. This is actually required for competition participation, and if we don't have a way to have the airframe eject the payload, we will not be able to compete in Huntsville. The system was not working at the start of the project due to missing code and electrical problems. So the 900 MHz work has been successful. Refactors have the code down from 600 lines to 200 lines, still fully functional with much better comments and documentation. Further testing and refactor is in the works. The old GUI is no longer functional, but the new GUI is in testing by volunteers, and will integrate the payload ejection control as well as an easy output for GPS coordinates. Work on the 433 band has not gone as well as we would like. A lack of manpower on the electrical engineering side of the project has pretty much brought it to a standstill. I am not able or educated or trained in the kind of manufacturing and electrical work that it would require to assemble the hardware. So instead, I have off-the-shelf prototyping components that I will be using to put together a prototype with code that I can hand off to next year's team so that they can develop it into a full system. As for the payload ejection control, we actually just finished development as of last week. It works, the code is documented, available on GitHub, and we have a functional and fully recorded ejection as of the last full-scale launch. In terms of what's left, the 900 MHz band still has small features to be implemented, such as ground station data logging for redundancy, the new GUI, new refactors and documentation, and etc. Last problems and bugs will need to be worked out before competition on April 2nd. For the 433 MHz band, this here is the OSU NASA USLI custom printed circuit board for the avionics telemetry unit. You can see it's operated using a TNT 3.6 microcontroller. GPS data is collected here using this U-Block GPS unit that connects to GPS, GLONASS, Baidu, and the Galileo satellite systems. This current unit is configured for 900 MHz transceiving. This here is the XB Pro S3 and connected antenna that communicates with the ground station. As you can see here, there is actually electrical capability for using the 433 MHz band, but unfortunately due to manpower and scheduling issues, we haven't had volunteers on the electrical front able to put together the 433 MHz hardware. The entire system here runs off of a 7.4 volt LiPo battery. It also has onboard data logging using an SD card. This way, during the flight, we can track and collect the GPS data for the flight path, and then pull it off, and then use a computer to analyze and sort that data. The avionics unit here connects to a computer using a micro USB cable with which we can reprogram the teensy microcontroller. This is the avionics telemetry ground station. As you can see, it's got a fancy black case with a handle here for transportation. It's almost like our very own nuclear football of sorts. The system itself receives data from the flight units using the XB Pro S3 here. We've actually got a fancy Funduino shield for coordinating the electrical signals. The system itself is also run by a TNT 3.6. I did not actually put together these electronic systems. This was done by last year's electrical engineers, and then just integrated here. So this unit actually also houses the ignition system. So CS didn't work on that, but basically using the same system, we can transmit the ignition trigger through this to the rocket while we're also running the avionics telemetry code. This unit also has the capability of data logging using an SD card. That was previously done through the GUI that we had, but that's not currently working due to the new hardware and avionics code refactors. So that's going to be one of our near-term goals, is actually logging the data here so that we can cross-reference between the two different ATUs. This system also runs on a 7.4 volt LiPo battery, which can be plugged in here. The leads are actually underneath the board. It just looks the same as the flight unit. So here we can see the avionics ground station in action. The code is written in the Arduino IDE. I also used VS Code for parts of it. The data is observed through the Arduino serial monitor. This is what we're mostly using rather than a GUI at the time being, to look at it, just because of ease of access and simplicity. So we can see right now that the ground station is actually receiving full packets with GPS coordinate data from the flight unit with the call sign summer. I've got timestamps on so we can see the packets are coming in about every 1 second. So we can actually see, I'm going to turn off the auto scroll here. So this is what the packets look like when there's a GPS lock. So GNRMC is the NMEA packet type. That's a GPS packet protocol. And then you've got your coordinate data here. There's a timestamp. It's in UTC. And then you've got like directions and all that. And so we can see there is an active RF link right now. This is over the 900 megahertz system. And I'll actually scroll up here and we can look at some other data. So these packets have occurred once the system on the flight unit end has initialized but hasn't attained GPS lock yet. So you can see the timestamps are correct, but there's commas here indicating that there's no data. The V actually shows that there's an error, as in it's not locked yet. And so if we keep going up, we can actually see that the units transmit even when they haven't initialized yet, and we can tell from that. And so we actually do have two. I've got data from another test here where we were running the other ATU with call sign Rick. So that's how we take in and view the data over the ground station. I'm not going to show a video of the flight unit just because it's very similar.
Hello, my name is Leif Seng, and I will be talking to you about our payload software. First, our payload software will be responsible for a few different things. We will begin movement after obtaining the GPS lock, and we will save the origin point from where we got that GPS lock to begin with. Then we will navigate away from the original GPS lock point. During this time, we will be practicing object avoidance to utilize the sonar. And during this travel, we will gather GPS data moving away from the origin location. After we are a specified distance, we will halt movement and collect the soil sample. We will realize that this is the specified distance because we are gathering GPS data along the way, comparing each point with the previous point. As you can see in this video, there are two sonars located in the very front of our payload. These will be searching at all times for obstructions in our path. We are looking for these obstructions via a thread located on our teensy. This will allow us to interrupt our teensy and have an open loop to steer ourselves away from any objects that we could become stuck on. We have a hard turn implemented. This means that we should be able to turn very hard and take those sharp corners. Full power will be provided to the turning wheel. The other wheel will be provided half turn in reverse. In this video, you can see the wheels on the motor turning the opposite directions when it detects an object. I put a cardboard box in front of the sensors, and you can see on the teensy That blinking light means that there is a thread going at the moment and is not being interrupted. GPS is a very important part of our payload. This will allow us to find the distance between the origin point and the very end point so we can figure out where we want to stop and drill for a sample. We will also be able to log the GPS coordinates, and we will be able to power off when we need to at the very end of our mission. Here in this video you can see that the rover begins to drive away as soon as the GPS lock has been acquired. In the video, we have the rover on a 5-second delay before stopping. However, in the more recent tests, we have been able to use the GPS on the rover to accurately gauge 100 meters and halt movement after the target distance has been reached. Here I have some pictures that came from the BeagleBone used to implement computer vision. The pictures on the left has been taken of the target along with multiple darker and lighter objects in order to simulate natural contrast that the rover might see outdoors. As you can see, there are no false positives for the circle detection and able to find the center point that is transmitted to the teensy. The picture on the right is using a candy filter. This is fine-tuned in order to show the minimal amount of hard edges for processing. This is a demonstration video of the BeagleBone processing the target and transmitting the location of the picture to the teensy in order for the rover to move towards the target for docking. At the moment we are dealing with some race conditions, as you will see the same wheel turn twice even after the rover has been adjusted. However, we plan to resolve this issue while retaining the highest frames per second processed by the BeagleBone. At the moment the BeagleBone is powered off my laptop to the right, but as soon as the BeagleBone can be powered off of the rover itself, we will begin movement testing.
So we just heard from Leif on how the rover software is going. So my name is Ryan, and I will give you a update on the website. So currently we have the skeleton code in for the homepage, deliverables, and about us. And so that was a lot of progress made over the past few weeks. One major issue that I've been running into, however, has been the styling, and I'll show that when I kind of go through a demo of what our website looks like. The pages that still need to be done, however, and need to have some information added is outreach and sponsors. So for outreach, that's kind of our community service deal that we do as a team. So I'm going to add kind of a photo gallery through it, and then sponsors are TA showed me a cool little template that I could do for showing off sponsors, so I'm going to have a lot of fun with that. I'm going to try and work on that over spring break as well as update the styling. So that's kind of a quick rundown of where the website currently is at. So what's left? The main thing is to really hammer down the styling. So I had been developing mostly on my MacBook Pro laptop, and recently I switched over to my desktop. I have one more screen, so it makes it a little easier for developing to have kind of two screens. Obviously, when I did that, my monitors are bigger than my laptop screen, so I was like, I should have been accounting for this at the very beginning, but developing for different screen sizes. So that kind of added on to the list of styling that I needed to get done. So I've been working on that. So the product that I'm about to show you was mainly developed for my laptop, and I had started to mess around with the homepage styling for my desktop screen, but the About Us and the Deliverables page is going to look a little funky. That being said, the functionality is there, which is the most important part. Now I just really need to hoe down the styling, which I've been trying to do over the past week or so, but it's going to be taking a lot of time. So here I'll show you the website. So this is our homepage, just to show you that I clicked on it. So we have our side navigation bar off to the left. We have our title up top with our logo. Um, and so and we also have a footer on the bottom. So we let me close out of that. So so that's there. So the home page will look like this. We'll have our USL, what is USLI? So we'll kind of have our mission statement as well as our mission, or our picture of like what we've been working on as a team. And so the styling for this has been kind of funky. I don't want it to be this big. I wanted to, take this whole picture of basically shrink it down in equal size, kind of how it was on the old website. And so you don't necessarily have to scroll to see the whole picture like this. And then add, what our mission statement still is on the bottom. And then what I want to do is upload a full rocket CAD or a CAD of our rocket shown here in this diagram, but that way somebody can come in and look at a more detailed view of what our rocket looks like. So here on the About Us page, so this is kind of a blank table. So on my laptop, I had this table. How it ends here, it was all the way down to the bottom of the footer. Now, obviously, because my screen's bigger, it's a little different. So, but I'll be able to fix that. And what I was able to do is I split everybody up by subteam role. The table is able to scroll when it overflows, which is what I was really struggling with, but I was able to figure that out. We didn't do headshots this year. If we were going to do headshots, I would have done a more traditional About Us page. There's still time for that, but that could be a project for spring term and or for the new guys coming in next year. The deliverables page, now this is going to look really funky and off. Again, I have a lot of work to do with the styling, but basically what I wanted to do was have this extend all the way down. I still need to mess around with the background image and what I'm going to do, but the grid layout is somewhat there, so you're able to I wanted to have 2 on each line and overflow scroll if need be, as well as scrolling down like this. Again, the styling is really not good at the moment, but the functionality is there. So if you were to come in, click download, it will download, click, and our proposal is right there.